Bismillahirrahmanirrahim. Welcome to PMBC online lecture. I am Bise Abbottabad. In this lecture, we are going to discuss average rate of change. Now, what exactly average rate of change is? When finding the average rate of change of a function, you are basically looking at how much y values of that function change versus how much x values change between two particular points of that function. Now consider the graphical approach to find average rate of change. Consider the x and y plane. Now consider this is a function. We call this f of x. Now to find the average rate of change, we are going to find how function changes between two particular points. Now consider two particular points. For example, we take this one point and this point on this function. In order to find out how much function changes between these two particular points, we are basically looking for slope of secant line. So let's draw secant line. This is a secant line. Secant line is the line which cuts the graph at 2 points. In order to know where these points lie, this point is x and it has moved to a distance delta x. This is delta x distance. So the next point will be x plus this distance, that is delta x. So x changes from x to x plus delta x. Now to check change in y. Now we see that this point lies on x point. On y-axis, the point will be f of x. So this point is x comma f of x, and the point has changed from x to x plus delta x. So the y point will be f of x plus delta x. So this point will be x plus delta x comma f of x plus delta x. Now we will use this strategy as change in y upon change in x. Now change in y is f of x plus delta x from f of x. So it will be the difference from final to initial point, that will be f of x plus delta x minus f of x divided by change in x, that will be x plus delta x minus x. So average rate of change will become delta y divided by delta x is equal to f of x plus delta x minus f of x whole divided by delta x. This is the formula for average rate of change. And average rate of change is basically the slope of secant line. So we can say that the average rate of change y for unit change in x is given by delta y divided by delta x is equal to f of x plus delta x minus f of x whole divided by delta x. The slope of secant line represents the average rate of change, which measures always the approximate rate of change in phenomena. Now we are going to practice some questions related to average rate of change. First of all, consider this example. Determine the average rate of change of y per unit change in x for y is equal to x square minus 6x plus 5 as x increases from x is equal to 1 to x is equal to 3. Now in this question, this is y, that is x square minus 6x plus 5, you can call it f of x, and x is increasing from 1 to 3. So this is the value of x and this is the final point, that is x plus delta x, that is 3. Now come to the solution. As we know that average rate of change delta y by delta x is given by f of x plus delta x minus f of x whole divided by delta x, we call it equation number 1. Now in this formula, we need the values of f of x as well as the values of f of x plus delta x. Now we know f of x, that is this function, but we don't know f of x plus delta x, so we are going to find it. We call this function y as f of x is equal to x square minus 6x plus 5. Now this is f of x. To find f of x plus delta x, we are going to replace x by x plus delta x. So f of x plus delta x is equal to x plus delta x whole square minus 6 times x plus delta x. We have just put x plus delta x instead of this x plus 5. Now taking whole square, we get x square plus delta x whole square plus 2x delta x minus 6x minus 6 delta x plus 5. We have just opened the formula of a plus b whole square over here. So we got the value of f of x plus delta x. Now putting the values of f of x and f of x plus delta x in equation number 1. So we get delta y by delta x is equal to x square plus delta x square plus 2x delta x minus 6x minus 6 delta x plus 5 minus x square minus 6x plus 5. Now we are multiplying this negative sign inside the bracket, so we got this result. Now we can see that x square, 5 and 6x are cancelled with the opposite sign terms. So we are left with delta y by delta x is equal to delta x square plus 2x delta x minus 6 delta x whole divided by delta x. Now we see that delta x is common over here, so taking common, delta y by delta x is equal to delta x times delta x plus 2x minus 6 whole divided by delta x. Upon cancellation, we are left with delta y by delta x is equal to delta x plus 2x minus 6. Now we cannot simplify it further, so we are using this condition that x increases from x is equal to 1 to x is equal to 3. Here given that x is equal to 1 and it is increasing from x is equal to 1 to x is equal to 3, it means that this is x plus delta x. Now we are going to find delta x from this, so we will subtract initial from final, that is x plus delta x minus x is equal to 3 minus 1, which gives 2. Upon cancellation, here we got delta x is equal to 2. Now putting the values of x and delta x in this equation, we get delta y by delta x is equal to 2 plus 2 times 1 minus 6 is equal to minus 2. So average rate of change, that is delta y divided by delta x is equal to minus 2, which is the required result of this function. Now consider another example. Find the average rate of change of y or unit change in x for y is equal to x square plus 4 from x is equal to 2 to x is equal to 3. Now consider the solution. As we know that average rate of change, that is delta y by delta x is equal to f of x plus delta x minus f of x whole divided by delta x. We call it equation number 1. Now we let that y is equal to f of x is equal to x square plus 4. Now we are going to find f of x plus delta x. F of x plus delta x is equal to x plus delta x whole square plus 4. We have just replaced x by delta x in this function. So opening the whole square formula of a plus b whole square, we get x square plus delta x square plus 2x delta x plus 4, which is the value of f of x plus delta x. Now putting the values of f of x and f of x plus delta x in equation number 1, we get delta y divided by delta x is equal to x square plus delta x square plus 2x delta x plus 4 minus x square plus 4 whole divided by delta x. Multiplying this negative sign inside the bracket, we get x square plus delta x square plus 2x delta x plus 4 minus x square minus 4 whole divided by delta x. Upon cancellation, we are left with delta y by delta x is equal to delta x square plus 2x delta x whole divided by delta x. Now taking common delta x, upon cancellation, we get delta y by delta x is equal to delta x plus 2x. Now we come to the condition that it is increasing from x is equal to 2 to x is equal to 3. This means this is x and this is x plus delta x. So here given that x is equal to 2 and x plus delta x is equal to 3. So delta x will be by subtracting initial from final value, that is x plus delta x minus x is equal to 3 minus 2, that is 1. So upon cancellation, delta x is equal to 1. Now putting the value of x and delta x here, we get delta y by delta x is equal to 1 plus 2 times 2, that is the value of x, is equal to 4 plus 1 gives 5. So average rate of change, that is delta y by delta x, is equal to 5. Consider another example, and this example is from exercise 2.1. This is question number 2. Okay, determine the average rate of change over the specified interval for the function h is equal to under root t minus 9 from t is equal to 9 to t is equal to 16. As the function is given as h, so here we will write the formula for average rate of change as del h divided by delta t is equal to, as h is a function of variable t, so it will be f of t plus delta t minus f of t whole divided by delta t. We call it equation number 1. Now let h is equal to f of t is equal to under root t minus 9. It is the same as we have done in the previous examples, like there we had a function y and the function was of variable x, so we call that y is equal to f of x. Here h is a function of t, so we call it h is equal to f of t is equal to under root t minus 9. Now we are going to find f of t plus delta t. Now we will replace t with t plus delta t. We get f of t plus delta t is equal to t plus delta t whole under the root minus 9. Putting the values of f of t and f of t plus delta t, this is f of t and this is f of t plus delta t in equation number 1, we get del h divided by del t is equal to t plus del t whole under root minus 9 minus under root t minus 9. Multiplying this negative sign inside the bracket, we get this. Upon cancellation, we are left with del h divided by del t is equal to t plus del t whole under the root minus under root t whole divided by del t. Here in the question, we are given that t is equal to 9 and t plus del t is equal to 16. Now subtracting, then we get t plus del t minus t is equal to 16 minus 9, final minus initial. So we get 7. Upon cancellation, we got the value of delta t, that is 7. Now putting the values of t and delta t above, we get del h upon del t is equal to under root 9 plus 7 minus under root 9 whole divided by 7. Now simplifying it, we get under root 16 minus under root 9 whole divided by 7, and we get 4 minus 3 upon 7 as 1 by 7. So here in this function, the average rate of change is 1 by 7. I hope you have understood the concept of average rate of change. Now consider some MCQs. Number 1. The average rate of change measures the derivative, instantaneous rate of change, approximate rate of change, or none of these. Well, the right answer is approximate rate of change. Number 2. The average rate of change y is equal to f of x per unit change in x is given by second option, that is f of x plus delta x minus f of x whole divided by delta x. The slope of blank line is the average rate of change, secant, tangent, straight, or none of these, that is secant. If a function changes from x is equal to 3 to x is equal to 7, then delta x is, well, we know that delta x is final minus initial, that is 7 minus 3 gives 4. The average rate of change of y per unit change in x for y is equal to x square minus 6x plus 5 as x increases from x is equal to 1 to x is equal to 3 is, this is the example number 1 that we have done, and we got the result as -2. Here is an assignment for you for your practice. Find the average rate of change of the following functions over indicated intervals. These questions have been taken from exercise 2.1. Practice them to understand average rate of change in a better way. Thank you so much for watching the lecture.